Today's the day that the X870E and X870E motherboards are launching. But on paper, it looks like basically the same chipset as X670E. But these are premium motherboards, now packing Wi-Fi 7, and the headline is faster DDR5 memory support. DDR5 8000? 8200? How is that possible? I've got the ASRock X870E Taichi and the Taichi Lite, both here to take a look at. Linux testing, Windows testing, full coverage on Windows. I've actually got 4 motherboards in all. X870E, 3 X870E and 1 X870 that we're going to cover over the next day or two that are just the launch boards. But there's more coming, and there's a lot to be excited about beyond faster memory speeds and more connectivity. But I actually found some interesting things. I think there's some things people are going to get wrong for launch day. And we need to chat. All right, first, let's take a look at what you get in the box. For the X870E Taichi, ASRock is leaning in to all of the RGB visual accoutrement. For the X870 Taichi Lite, ASRock eschews all of that. This is a really awesome trend, I think, from ASRock, and they should be commended. If you want the same electronics with the same features, there is no compromises in terms of how it functions, the Taichi Lite is for you. If you're going to build a really awesome build to show it off, and you can have a glass side panel and you want to see what's going on, there's a lot of RGB insanity for the X870E Taichi. That's the price difference. Do you want the visual accoutrement or not? They will function very, very similarly. It's a 24 plus 2 plus 1 power phase design. USB 4 is on board. That means that you have compatibility with Thunderbolt peripherals generally. PCIe tunneling over USB is a USB 4 feature. It's an optional USB 4 feature, but I'm happy to report it is implemented on these motherboards, which is exciting. That's a thing that has piqued my interests since I shoved Thunderbolt binaries into a Threadripper motherboard at the dawn of time, and it actually worked. I was able to run Thunderbolt as a PCIe device, basically. Hotplug was not amazing. But USB 4 is a lot of hard-won engineering that I'm going to take credit for, but actually people did all the work, and I just sort of ham-fistedly glued it together and got it to work because of their hard engineering. And it's nice to see it productized in USB 4, so amazing. This is an 8-layer PCB. The fastest NIC here is a 5G NIC, but the Wi-Fi 7 interface, if you're using the Asus Spider Crab, which is what I use to test these with, it's really high-end Wi-Fi 7 device. If it's in the same room about 4 feet away from your computer, you can get 5.7 gigabit. That does require a 320 megahertz channel width and some other Wi-Fi settings that we'll talk about, but the wireless card is faster than the 5 gigabit wired card in a best case scenario. Yes, that's true. Wi-Fi should not be faster than wired. That's just not a thing. And to be clear, we're talking about transfer speed. The latency is still higher on wireless. Wired is a lower latency. So latency is good for gaming, low latency. The X870E Taichi also features an easy release GPU design so that you can push a button and release your GPU. You don't have to try to wedge something in there. If you need to take your GPU out or in, you're not going to break the retention tab, as has happened around the office several times. The 24 plus 2 plus 1 power phase design mean that you can overclock your 9950X to your heart's content. And oh boy, with that fast memory, that's what I think a lot of people are going to get wrong. Well, I can't wait to talk about that. It's something interesting. This platform does support 4 DDR5 DIMMs. My recommendation to only use 2 DDR5 DIMMs, however, holds, and we'll talk about that. 2 PCIe 5.0 X16 slots. They can run in a by 8x8 configuration. This CPU doesn't have enough lanes to run 2 PCIe Gen 5 slots at the full X16. Of course, if you only use one, you get the full X16 bandwidth, no problem. We have 1 blazing M.2. That is a Gen 5. We have 3 Hyper M.2, that's Gen 4, and that's 4 lanes. And we have 6 SATA 3 ports. The rear connectivity, we have our antenna ports. We have our 3.2 Gen 1 Type A, 3.2 Gen 2 Type A on the top and bottom there. 2 USB 2 ports, 2 more USB 3.2 Gen 2 Type A. Then we've got our 40 gigabit USB 4 ports And then above that, we've got our USB 3.2 Gen 1 Type A ports. Well, one of them's Gen 1, one of them's Gen 2, so 5 and 10 gigabit. Then we've got our single 5 gigabit LAN, and then our audio out, and then our microphone in, and our optical SPDIF. It has one HDMI output, and the two USB 4 Type C can also do DisplayPort alt mode. In the box, you get an RGB extension splitter cable, a very, very nice Wi-Fi 7 antenna. This type of antenna for Wi-Fi 7 is basically required if you want to get more than about 2 gigabit, so nice to see it in the box. Now, our blazing M.2 is also a quick release mechanism. I love this. If you've been a follower of Level 1 for a long time, you know that I get kind of lazy when it comes to mounting the M.2 because I'm taking things in and out. Not only is the heatsink itself quick release, but there's also a little mechanism for retaining the M.2 itself. Now, when you use this, be sure to peel off this plastic, which prevents the thermal stuff from reacting with the atmosphere, because you want it sandwiched in there and you want it to make good contact, because the heatsink is pretty much necessary for these faster Gen 4 and Gen 5 M.2. I've had several M.2 murder themselves because they overheat the faster ones. Your other M.2 on the lower part of the board, you still use screws for those. That's okay. And then your quick release. Now, technically, ASUS patented their version of this, so this is a different mechanism than what ASUS uses. But it's still a very effective mechanism for making it easy to remove your GPU. You've got another Gen 4 M.2 at the front edge of the board here with the quick release stuff. You know, 2 M.2 is about right. Like, I wouldn't recommend going ham with M.2 devices. So the 2 here that are on the board, yeah, it's fine. I mean, you can add some more, but these 2, it's all you need. Now, in terms of board layout, at the top edge of the board, we've got dual 8-pin connections. We've got our CPU fan, our water pump header, and our secondary CPU fan header. So that's 3 4-pin fan headers at the top. 2 digital RGB headers at the top. Our postcode readout, a physical power and reset button at the top edge. Our 24-pin ATX power connector. Our 20-pin front panel USB 5 gigabit Type-C port. Our 6 right angle SATA ports. Those are SATA 3. Then we got another 20-pin 5 gigabit front panel USB connector. So this board can support a total of 4 Type A ports and 1 Type-C port. At the bottom edge of the board, we've also got 4 more 4-pin fan headers, including a second water pump header. We got 2 USB 2.0 headers, so you can run another 4 Type A USB 2 ports on this, or use it for internal accessories. We've got another digital RGB header, and then our front panel audio connector. At the mid-board, just below the CPU socket, between the CPU socket and the DRAM, we have another 4-pin fan header. That's a total of 8 fans supported on this motherboard. Very nice. We also got about a pound of heatsink here. That's a lot of heatsink for our VRMs, and it had better be, because each stage is 110 amps. That is beyond overkill for AM5. I mean, that 9950X, the TDP there, this could run like 4 of them. That means we can overclock, right? Oh, yes it does. The rear of the motherboard also has this cool backplate that is thermally connected to the PCB, so this acts to help with heat dissipation. Mainly the VRM area, but hey, I'll take it. Oh, and I forgot to mention the rear I.O. CMOS clear and BIOS flashback. So when the inevitable BIOS update comes for the X3D variants or something beyond 9,000, it's over 9,000, you can flash the BIOS without having a CPU. Also in the box, we have a Taichi Cherry style keycap, the ASRock quick installation guide, 4 USB cables, and 3 analog thermal sensors. So these basically plug into a header on the motherboard, and then we'll give you a temperature readout of other stuff wherever you've taped them. Could be storage, could be your GPU, could be your power supply. Heck, you could even run it around to your air intake so that you know what your air intake is. And then you can use the fantastic tuning, ASRock, puns after my own heart, to control your fan profiles based on the temperature sensors that are actually on the motherboard, the temperature sensors built into the CPU, and the temperature sensors in the box. It really gives you a lot of control. As for the Taichi Lite, it's pretty much the same motherboard bundle. You get the same RGB breakout cable, you get the same really nice Wi-Fi antenna. The only difference is the motherboard itself. The Taichi Lite doesn't have the rear connection, the rear metal backplate cover with thermal connection, but it does have the same 110 amp power phases. It's the same power phase design We only have the one quick release blazing M.2. That's good enough for me. This is a screw-based solution for your M.2 at the front here, and a screw-based solution here. The heat sinks for the motherboard are simplified a bit, but you still have a really big honking heatsink for your VRM. And this is still way, way overkill, even for a 9950X, in terms of power delivery and everything else. The motherboard layout is identical. The fan headers, the USB Type-C, the dual USB, 5 gigabit connections. You can still support 4 Type-A. Electrically, this motherboard is identical. 8 PCB layers, etc., etc. Same exact rear I/O. Everything is basically the same, except you don't have the onboard accoutrement. You don't have quite as much coverage. You don't have the rear backplate. But otherwise, same. Does that mean it benchmarks the same? Why, yes it does. It's amazing. Obviously, the choice of Linux users. Duh. Now let's talk numbers. Numbers from these motherboards. 80 gigabytes per second. It is the fastest score that I have ever seen in AIDA64, period. With a latency of 71 nanoseconds. Now, I have been able to achieve better latency, but that's because we're running a DDR5 8200. 8200. And keep in mind, this is with two 48 gig DIMMs. The higher capacity DIMMs are even a little bit more of a challenge. 48 gigs? Yeah. The new DDR5 standards with the onboard memory controller mean that the DIMM can operate itself at 1.1 volts, as low as. So, this sort of generation 1.5 DDR5, or this DDR5 refresh, sort of incorporates the learnings of dealing with DDR5, including minor board layout changes and everything else. So when you look at this, it's like, yeah, physically there's not a lot of difference between the X670E chipset layout and the X870E chipset layout, except this is a motherboard refresh to incorporate the learnings of dealing with things that gotta go fast in the new platform. So yeah, the chipset's basically identical. There's some more, you get, I think a couple more USB ports. And that's basically it. But it really undersells what you actually get if you can achieve 80 gigabytes per second of memory bandwidth. And this is the part that I think a lot of reviewers are going to get wrong. If you run a 4090 with this, and you're running DDR5 8200, and you spend some more time tuning the memory to get the latency even a little bit lower, even though you're running, sort of an asynchronous configuration with the Infinity Fabric and the memory configuration, which, as I'm sure you know, it's a better situation on AMD when all of those things are synchronized. Or you go off roadmap and you want to run, 2200 or something like that on your Infinity Fabric. 2200 on your Infinity Fabric is completely fine. But really, what we're talking about here is the fastest AM5 platform you can get. And with that, with the fastest GPU you can get, then you can get some of those really absurd frame rates in games, but generally only at 1080p or 720p on low settings. Don't think anybody actually games like that, and I think it's a little disingenuous to say that. So there are going to be reviewers, probably, that say that this unlocks a whole other level of performance with the 9000 series Ryzen CPUs, and that's not untrue, but you have to take that with a grain of salt in that at 1080p, yeah, pretty amazing. But if you move up to 1440p or 4K, there's almost no difference because those things weren't the bottleneck anyway, meaning memory access, bandwidth, and latency, and everything else. And also, good lord, that's fast. One of the other things that I was looking for was MOPP, and I didn't see it in the BIOS. This was the thing that AMD had demoed that in the BIOS would say, hey, your memory, even though it's DDR5 8000, we could run it at really absurdly tight timings with the 1-to-1 fabric ratio, 2000 infinity clock, blah, blah, blah. And that would also be a benefit in that you're going to get your latency really super low. At 2000, 2066, 2133, I can get absurdly low memory latencies as reported by AIDA64, which again, take with a grain of salt because AIDA64, but like 59, 62, 65 nanoseconds, which will help with those low resolution, high frame rate gaming benchmarks. I'm going to spend some time tuning it. It's not really a big deal. It's pretty easy to do. You just got to spend time with it and got to feel out your memory kit. And that brings me to 2 DIMMs per channel. Now on these boards, 2 DIMMs per channel is a lot better, but I still see a lot of people on the level 1 forums that are trying to get DDR5 5600 to work with 4 DIMMs. Generally, that's not advised, because even if you get it working, it's usually not stable. It might be stable as long as you're fully loading the machine, but if you leave it idle for a while, or the memory cools off, or the memory is unusually warm, then instability can creep in, and nothing is more annoying than a computer that is slightly unstable. 3800, 4000, 4400 is still the recommended configuration, but on these boards, 5200 across all 4 DIMMs works for me with 48 gig DIMMs, where that was a little sketchy on basically all other boards. And that's on 8-layer boards. Generally, I've had better luck with DDR5 when we're talking really absurdly high-end boards that were more than 8 layers, which are basically unobtainium unless you've got, well, that's a conversation for another day. But the fact that they're able to do that with 8-layer boards now is hugely impressive. Good job, ASRock. I mean, DDR5 8000? Well, DDR5 5200 with 4 DIMMs was attainable for me, sample size of 2, with some pretty good DDR5 8000 memory, matched kit, running at 5200. Now here's the other thing. When you get 2 kits of memory to run in 4 DIMMs, you have to put a kit of memory in a channel. You don't spread them across a channel. This is making your life unnecessarily difficult. Even exactly identical memory can be binned or go together. So if you get 2 48 gig kits of 2 DIMMs, put the DIMMs from one kit in channel A and the DIMMs from the other kit in channel B. This is more likely to work properly. It's kind of wild, I know, but trust me on this. You can engage in the forums if you have experienced something different. But a lot of people have already engaged in the forums and said, holy crap, thanks for letting me know. It's fixed now. Except for the people that are still trying to run 4 DIMMs at DDR5 6000. And a couple of you have succeeded. Good job. Would you like a cookie? Would you like a badge in the forum? I'm sure that can be arranged, but it's not realistic for normies to expect that. It's not even realistic to just, even really amazing talented people, because it's down to silicon lottery and board lottery and everything else. Now, the out-of-the-box performance with this and Cinebench R23 is almost 42,000. If you just enable PBO, again running DDR5 8000, you're going to get more like 45, 46,000. 5.2 gigahertz all-core, not really a problem. If you want to run 5.3 gigahertz on your good CCD, like 5.1, 5.2 on the other CCD, you can do that. In case you're not in the know, this has been like this since time immemorial. For chips that have 2 compute chiplets, AMD usually gives you one that'll clock really high, and one that is uses less power, but clocks a little lower. It's a pretty interesting strategy for staying under the the TDP budget, and if you want to overclock, generally you want to focus your overclocking efforts on the primary CCD, the one that clocks higher. And for my, again, sample size of 1, 9950X, for my 9950X, I can get 5.25, 5.3 gigahertz, mostly stable on the one CCD, no problem. And that means my Cinebench R23 scores are going to be, almost 46,000, which is pretty impressive. And that's also without breaking the power budget, which is, on the order of 225 watts max. For gaming, of course, it's not going to touch that. So bear that in mind. Single core boost on the 9950X in this configuration, 5.7, 5.8, easy. Storage. For storage, I got tired of screwing around. I bought 4 T705 4 terabyte SSDs, and these can do 15 gigabytes per second all day long. And on this platform, even while I'm doing lots of other crazy stuff, AM5 delivers. AM5, 15 gigabytes per second. T705, yeah, it's a really nice SSD. And with this cooling solution that ASRock provides, it worked really, really well. This SSD can be a little bit of a struggle to cool if you're not careful, and it will throttle. It actually has, I think, 3 stages of throttling. I reviewed the, 2 terabyte version of this, but I decided to pick up 4 of these to test with my 96-core Threadripper system. I've got a separate video coming on that with these 4 that's focused around a storage benchmark, but I borrowed one of these to be able to test this platform, and oh boy, that's really nice. want to kind of splurge for that and put that in my own gaming system, but I just got to run benchmarks all day long. So fun times. So many terabytes, 16 terabytes. Now, could you run RAID 0 with those and have 8 terabytes of storage? You could. I still don't really recommend AMD RAID. Like, it could be awesome, but you really only have the 4 Gen 5 lanes directly to the CPU. Your other connection would be Gen 4. Really, you're probably better off getting a fast boot drive that also has lots of capacity for your games. And then you can get a lesser expensive, slower drive and, you know, do that 1-2 punch with your M.2. I don't think it's worth fooling with storage, NVMe storage RAID in 2024. It's too much of a headache, and especially it's too much of a headache on the AMD platform. If there was an argument for doing that on the Intel platform, maybe. But mostly no on both platforms, and especially no on the AMD platform. You don't, just get a bigger SSD, a bigger NVMe SSD. 4 terabytes is nice. Now, I mentioned about the Asus Spider Crab router. That's not actually the product name. I'm just lazy. But I did do a video on it where I got the correct names, like RT something something. I don't know, Asus and their product names. But it is a solid piece of kit. I can see some incredible improvements, mainly a lot of storage and a lot of RAM, being able to run a custom operating system on it. But the out-of-the-box operating system gets the job done to the tune of 5.7 gigabits per second for your network connection. You'd need a 10 gigabit internet connection to outrun it, and that router delivers with this board. In order to do that, you're going to need to configure a 320 megahertz channel width. Mine was 37/320-1 for the control channel. That was with WPA3 and AES. I also had to configure up to MCS 13 4096 QAM on the modulation scheme configuration page, because without that, it didn't work. Well, not at absurdly fast speeds. Moving around my office a little bit, I was able to achieve 2 to 5.7 gigabit, but when it's in the same room and the antenna has line of sight to the Spider Crab, 5 gigabit, pretty reliably. And this is a challenged RF environment, so that's very, very impressive. My brain is slow as the RTBE96U. My brain's very slow. I have to sort of pre-cache things. And anyway, I'm one of those level 1 that's been looking at the X870E Taichi and the X870E Taichi Lite from ASRock. I like the X870E just because it's a refresh, and it's very nice to see these features. It's very nice to see this product strategy from ASRock. This is the pretty board, and this is the light board where they have cut everything that they can possibly cut, but still give you exactly the same performance. So all the Linux people and all the people that want the best of the best, but without paying for something they don't want, they're going to get the Lite. And somebody that wants, you know, fancy RGB-ness, well, there you go. I'm one of this level 1. I'm signing out. You can find me in the level 1 forums. Let me know what you want to see. All right. Signing out, and I'll see you there.